So today I'm make a video about my FastIO library to Lua. Okay, to Lua. So what we're doing here is that we have a C++ file, and I find that if we want to run it, we need to use a software called wasm2lua, which means first we compile C++ to wasm, okay, to wasm through clan. Okay, then use this wasm file with wasm time. Well, no, not wasm time. Not wasm WL, it's not a virtual machine. Okay, so with wasm, then we compile wasm with wasm2lua. Then we can get a Lua file. Now after this Lua file, we need to run this Lua file with Lua JIT. Then we can run this file. We can just use Lua JIT to run that file. But first, what we need to do is that I'll find that we cannot just directly compile the code that would run to Lua. We need to create our more entry point. So create this entry point, we need to copy this wasm lib. This is coming from the wasm2lua project. You can just find this file from wasm2lua project. And this file, it provides all the syscalls we need. Which means if you're in system that does not use this system, you want to just create your own write file function, whatever, then we just create this with wasm, right? I think this should be a little bit optimized. We should use concat, right? You shouldn't just use this. Whatever. After this function, what we are doing is that we go here and import this wasm file, and import this library. Then import the Lua file we compiled from the clan, from the whatever clan. Then we get the library. Then we need to put the imports here by using our module's memory file, memory table to initialize this function, then to give us the syscall here. Then we can just call init functions, then we call start functions, the function will run. So let's just try it. So I have write a makefile, but I want to just show you here with directly. Now we can run the makefile. I want to show you the process here. So we just like compile our normal C++ program, right, on the Linux. Now, but we are using clan, we need to put LTO, fuse LD equals LLD. Then we need to put include file, include our FastIO, right, for the library here. Then what we are doing is that we need to use this WASM, WASI, needs to target and sysroot. So you might ask, where can I get the sysroot here? Well, you need to compile that by yourself. So we can have two kinds of sysroot. First is using the GNU, the GCC's libstdc++. You all use LLVM libc++. So in my torsion, I just put in cross here. I have all sorts of cross torsion, and you can just do this. So we are going to do is using home dot cross. Anyway, done. But we are not just done. We also need to disable exceptions, because the exceptions is purely nonsense, right? Now we need to put these powers here. These synchronous unwanted. Disable everything related to the exceptions. Then it should done. But we can also do something like libc through C++, right? But they said we cannot run because C++23 does not work for clan. It works for GCC, but does not work for clan. We can either use libc++ or using libstdc++. So here we are just using libstdc++, okay? Which means libstdc++ is like what I compiled from GCC. Okay. Now you can see here we have C++. We have 20 using GCC 12. We compiled the GCC with it. So this is basically using GCC's facilities. We compiled this file. Now what we are doing is that we are going to run this wasm file. But first, now we have a wasm file. With wasm file, we need to use it wasm file with wasm2lua, then compile this wasm2 file to the Lua file. Now we have the Lua file here. So in this Lua function, what we are going to do is that we're using this do file function, load entire Lua file to WASI and load entire hello world wasm2lua file, load that into the module. So we load them. We load both of them, then we can just using Lua JIT to run the main function. Now we get the function working here. So it doesn't matter whether you're using lib. I don't think you can run with lib std C++. It's, I just using special things to compile GCC's libs to C++ with the function. If you're just using lib C++, that's also fine, right? But we need to put, I think we should just put std equals C++ to be equal to 1. So this is basically a sum. Let me jump to GIT. However, if we try to run anything else, if we try to run anything that can relate to heap allocation, for example, we just do this, then it will call master libc C++. But now if we just try this file, we'll see Lua JIT going to complain we have all the memory access. This is definitely a bug in the wasm2lua project. I think I've reported that bug. But in general, it's just a bug. So here, chart. I still don't know why he's doing this. I think probably we can just do a little bit of optimize of this function, string chart. Then we're going to do is that we're using a table. When instead of just creating a string, we create a table. Okay, I have a long time not writing. Basically, we can use Lua's table.concat. So we put a tb here, tb.t. Then we put all the table here by using by contacting. Okay, so yeah, we're gonna do this. Okay. Then we're gonna do is that we just call this string char function. The memory dot here. Okay. Then what we're gonna do is we concatenate this string. This string. I don't know whether you can just directly call write. I don't know whether. I think probably Lua should be able to allow that, but here we just replace that function to see whether it's gonna work. Table.concat. Then we concat with it. Let me just check whether it works. Oh, it works, but although it works, it has nothing to do with whether with wasm2lua, which means it's wasm2lua's bug here. I think I report that bug, it's not no problem at all. So we just run here. Oh, we haven't run wasm2lua, right? Okay, no problem, right? So it also works. Also, we can just try to use this minimum. We can just do. Oh, let me see. Let's just try see. So here he has a tower which is minimize here. We can just minimize it, minify here to 3. I think probably they want us to create our own heap, whatever. But I don't quite know. Whatever. I don't know. I just first report bugs. Maybe we can do it later. And after that, I'm going to try to see whether we can compile C++ code to Lua, then run on Warcraft, running on games to see whether it works on games. Okay? Then we can just no longer write Lua code anymore, just write C++. Okay? You just comport all your C++ code to Lua. We're done. Okay? So let's just see the binary size. The binary size is 10K. Okay, after Lua file with fastIO, which means it's even much smaller than C++ IO stream, Rust, or even stdio, whatever. It's just smaller, very small. Because here, if you look at what assembly does, we can just try to not use verify. The minify does is that we just like JavaScript, we're gonna remove all the space here. But here we're not removing the space. We're gonna just see what the function is doing. So in the main function, we can see the compiler is fully optimized all the code we need, and it just becomes a import or write fd write. Okay? Nothing else. Okay? See, this is nothing else, right? It just directly compiles C++ code to Lua with the wasm syscall, and it's done. Okay. So this is basically the entire function is doing. Okay. Now we have the C++ file compiled to Lua. That's it. Maybe I'm going to further investigate on why the heap allocation could fail, because I tried IOStream. IOStream would also fail because they're not doing the. I don't know why. Okay, but in general, FastIO works because it doesn't use any heap allocation. That's why you don't have the problem. Or maybe even the I think I understood what happened. I understand what's happening here. It requires you to use a special heap table here. Probably gonna try it later, but I'm going to not show it here in the video. Probably gonna show in the next. So to do that, I have already provided a huge Lua the make file here. We can just directly call make. But you need to, if you want to compile it, you get the systroot here, because here the systroot directory is clearly not on what the systroot on your machine, right? It's on my machine with this settings, but it doesn't mean it's running that on that machine. So we can just directly first make clean, then we just directly run make run, because make run will just do the same thing. Okay, like we can see the code is compiled and everything's run correctly. Of course, you would never be able to remove this stupid tower. You would never be able to remove stupid C+ exceptions, because C+ exception is definitely a huge disaster, I have to say. There's no way you can pause that exceptions to Lua, right? How do you do that? Despite Lua has the exception handling mechanism, you cannot expect the exception handling mechanism in Lua to work the same way as it works in C++, right? I don't know whether they will provide, at least the client doesn't support those things here. But I don't think we would need that either, because with the new herb session mechanism, we just simply don't need that. Okay, that's all about the entire video. I hope you enjoyed, but you can just join the Discord if you have any question to ask me about that. But in general, I think it's quite fun. We can run the FastIO library, just directly port to the WebAssembly. That's interesting. That's very cool. Okay, that's it. Thank you for watching the video.